Okay, so this is question 2. Hydrochloric acid, HCl, reacts with sodium hydroxide solution to form sodium chloride and water only. So you'll notice that it's the hydrochloric acid and sodium hydroxide again. It's possibly the most popular combination of acids and alkalis used in your exam. Write a balanced symbol equation for this reaction. Okay, so this does assume that you can you know a couple of formula and that you can balance an equation. So we've got HCl, which we could put the state symbol AQ as it's dissolved in water, an aqueous solution. Sodium hydroxide, it's not given to us here, so it's assuming that we could work it out from the table of ions, because sodium is Na plus and the hydroxide ion is OH minus. So from your year 10 work, you could work out that its formula is that, and that is a aqueous solution. And then as we've got hydrochloric acid, we know we're going to get a chloride, and as we've got sodium hydroxide, and that the chloride is sodium chloride. So sodium chloride is simply NaCl, which again is dissolved in water. And as this is the reaction between an acid and an alkali, then our other product is water. Okay, and if we do a quick check, this equation is already balanced. We've got 1, 2 hydrogens and the oxygen, which combine to become the water. And then we've got a chloride and a sodium, which becomes sodium chloride. So with the same reaction, a group of students were asked to find the volume of hydrochloric acid solution needed to neutralize 25 centimeters cubed of sodium hydroxide solution, which hopefully sounds very familiar to you. They decided to titrate sodium hydroxide with hydrochloric acid. Okay, now they did it with some slightly more advanced equipment, although we did discuss this afterwards. So this piece of apparatus here is called a pipette, and this is a pipette filler. Okay, there's a couple of different designs of pipette filler. This one's got a wheel on it, which you wind up to suck the liquid into the pipette. Okay, and then it's labeled X because the first question asks you what is it called. This part of the reaction here should be familiar. This liquid here will be transferred into there, and then the titration happens with some indicator. So we've got here 3 reactions, okay, with 3 values, 18.2, 17.8 and 18.0. So those are reasonably close for some GCSE level titration. And the first question asks us to name the piece of apparatus X, which of course we've already discussed, and that's a pipette. Okay, so a graduated pipette, although graduated pipettes tend to look a little bit like measuring cylinders. Explain the purpose of the indicator. Well, it's to indicate the end point or neutralization point of the reaction. It tells us when there is sufficient acid to neutralize the alkali in the conical flask. And there's a variety of different indicators you could use, but phenolphthalein is quite popular for this reaction. Right, calculate the mean volume of hydrochloric acid needed to neutralize 25 centimeters cubed of sodium hydroxide solution. Okay, now there are 3 results here, and they vary by a total of 0.4 centimeters cubed, and there are no 2 that are grouped together, so we are forced to use all 3 of them. Okay, so I would advise to use a calculator in this instance under exam conditions, so you don't make any errors. So we've got 18.2 plus 17.8 plus 18. Okay, and then if you press the equals button first before you press the divide button, that will remove any BODMAS errors that your calculator might introduce, and then divide by 3 gives us 18.0 centimeters cubed. Okay, it's important to put the 0 in because that shows that you are being as accurate as the results were in the first place. You'll notice the 0 is there. Okay, the next part. The change in temperature during the reaction can be monitored using a temperature sensor. So this isn't something that we did, but if you think back to evidence for a chemical reaction in year 10, a variety of different things we look for, and a change in temperature is one of them. Okay, so if the temperature is changing, then we can assume a reaction is happening. For this particular reaction, it is exothermic. It does get warmer, okay, as the reaction proceeds. So we might expect the temperature between 0 centimeters cubed of hydrochloric acid and 18 centimeters cubed of hydrochloric acid. We would expect a reaction to happen. So we might expect the temperature to rise for that first part of the reaction. However, it says a total of 30 centimeters cubed is added. Now, at this point, the reaction's over. There is no more sodium hydroxide left to react with the hydrochloric acid. So all you're doing is adding cold hydrochloric acid to the vessel. So the reaction temperature will start to go down. It won't go much below the starting temperature because that's the temperature of the liquids when you start it, or it won't go below the starting temperature because that's the temperature of the liquids before they reacted with each other. Okay, so that there is the you might want to add that that's around about 18 centimeters cubed. Okay, the experiment was repeated using hydrochloric acid of half the original concentration to state the volume of hydrochloric acid that would be needed to change the indicator color. Okay, so the hydrochloric acid is the liquid in the burette, which are these values here. If it's half the strength, then we would need twice the volume. Okay, and as we've calculated the average volume here, if we double that, then we get 36 centimeters cubed. Okay, so I'll put the 0 in again to show the accuracy that we're working to.